Okay, so now we are going to be doing some problems on polynomials. These are like some example problems I'm going to walk you guys through, and this will give you like a grasp on how the topic works, and so you can maybe solve some more problems yourselves. So the first problem we have is written over here. For what real values of k do the following two polynomials have a common zero or root or solution? So first thing that we want to notice is that it is impossible for both roots to have both the same two roots, because then they would be the same polynomial, only differing by like a scale factor basically. So they cannot both have the same two roots, so they can only have at most one root in common. So there are two main ways to solve this, and I'm going to outline one of them and show you and go into detail on the other solution. So the first solution requires a bit of wishful thinking, or like a bit of thinking outside the box. So what we can do is we can pretend that, let's say r is the common root, or let then what we would have is that if we substitute r into both of the equations, we have 1988, or wait, this equals 0, and this also equals 0. And now what we can do is we can subtract these two, right? We can subtract this from this. So it looks like this. So the reason why we would subtract it is because the k terms will cancel out. So if we subtract the two, then what we get is so basically if we factor this, we get r 6903 r squared minus 6 and minus 1 is equal to 0. So that means the root in common can only equal positive 1 or minus 1, because both of them squared will be equal to 1, and then so this whole thing will be equal to 0. So now we can test each case and then by substituting into the original thing. So I'm just going to substitute into this equation here, but it doesn't really matter. So 1988 r1 squared plus k1 plus 8,891 is equal to 0. So 1988 plus, or wait, let me just add this. So okay, 10,879 plus k is equal to 0, so k equals negative. And if we test r equals negative 1, then we have 1988 negative 1 squared plus k negative 1 so 10,879 minus k is equal to 0. So k is equal to negative 10,800 is equal to just positive 10,879. So that means the values of k are positive and negative 10,879. So this is the answer. Now there is another way that we could have got into the solution, although it is a little more complicated, or not necessarily complicated, but a little more tedious. So what we could have done is we could have just used the quadratic formula twice. So we have so the two variables, or not variables, the two polynomials, we can just use the quadratic formula on both of them. So is going to be equal to k squared minus 4 times 1988 right? And this is going to yield us x1 and x2, let's say, and then this is going to yield us x3 and x4. And then what we would then do is set the example where x1 is equal to x3, x1 is equal to x4, x2 is equal to x3, and x2 is equal to x4, and we would solve for k. But obviously this is a lot more tedious, and we have these massive numbers over here, so this is definitely not the way that you want to do it, although it is technically possible. So I guess the main takeaway from this problem is sometimes you want to just look for like creative substitutions or ways to solve the problem without necessarily brute forcing it. So this is just, I guess, something. These techniques are both the techniques for like substituting using like roots and stuff. It's pretty common in these types of questions. So I guess as you solve more of these problems, you'll start to see them more. So we can do one more problem, and I'm going to write down the problem here. So let's say this is a polynomial with roots. Find P of 1. So, you guys can pause the video and then see if you can figure it out yourselves, but I'm just going to jump into it. So the way that you would solve this is, you know that P of R is going to be equal to R cubed plus R squared minus R squared R minus 20, right? But what else does P of R equal? Well, since R is a root of this polynomial, then that means P of R is also equal to 0. So this means that if we can also notice that these terms cancel out. So it just becomes R squared minus 20 equals 0. So we don't even need to evaluate R equals positive, negative square root of 20 because we want to find P of 1, right? So that means we already see that this coefficient here is just R squared, so we just substitute this immediately. R squared equals 20. So P of X is equal to R cubed plus, or not R, X cubed plus X squared minus 20 X minus 20. So then P of 1 is equal to 1 plus 1 minus 20 minus 20, which is equal to negative 4,038. And that is the answer.